Okay. All right, we're recording this now. So kind of to start off with, do you have any questions for me about anything in the class, anything with the lecture, the readings this week or case studies, whatever? No, feeling pretty good about it? Okay, so have you had a chance to look at the semester project yet? Okay, you've looked at it a little. Just kind of I want to kind of take a few seconds and just talk about a few just helpful little hints and things. Let me pull it up and I'll share a screen and you can see. There we go. Okay. Okay, James, welcome. Glad you could make it. Let's see. Okay, so I just want to take a few quick seconds just to start off here and just go over a couple of things just with the semester project, the final natural disasters summary. It's still a couple weeks out, but I would recommend getting a head start, moving on it now. This is a pretty big project. So as you guys know, if you've had any time to look at it, you're going to do write-ups on 2 earthquakes, 2 volcanoes, 2 flooding disasters, 2 mass wasting disasters, 2 weather-related disasters. That'll be like hurricanes, cyclones, tornadoes, things like that. And then 2 other natural disasters. That's going to be anything like sinkholes or wildfires or things like that we haven't necessarily covered in lecture. So those will be kind of what's on it. And I would recommend if you go down, this is just, in the announcement I post on Monday, there's a link to this page. If you just go down to here to number 8, and it kind of talks about how the semester project must be done in Microsoft Word or another compatible format. Must be listed in categories and then chronological order. But anyways, when you see below that where it says like location of disaster, type of disaster, beginning dates, ending dates, stuff like this, I would recommend just going through and literally take this out, take the section I've highlighted right here, copy and paste that into your Word document, and then just fill it out in good paragraphs, well-written sentences. And this will make it so much easier for you to write up. It'll make sure you have all the information you need. So I would just recommend using this as a template for everyone. So, and you can even leave it in the bullet points and just write a paragraph right there or right below it. Just make you guys' lives a little easier. Okay, let's see. Other than that, a couple other little things here. With the disaster report, I would recommend you guys try to find the most recent ones, but sometimes it's kind of hard. For example, like volcanoes don't, typically affect people quite as often as we might think. So, if you need to go back a year or something to look up a volcanic, eruption that affected people, that's fine. Just, try and find the most recent ones you can. Just remember, it does need to be a natural disaster. And a natural disaster has to affect people to be a natural disaster. Any questions on that? Okay. Let's see. Stuff chat. Let's see what we got. Okay, great. So yeah, and sorry, I didn't see the chat until just now. So yeah, you don't necessarily have to use the disasters you've been writing about, but you're more than welcome to. It'll make your life a little easier. And if you haven't been writing about disasters that you want to use or that you feel really apply to the project, you can still start in the last remaining weekly disaster reports. You can start using ones that you feel will apply, and it might just make your life a little easier. So I would recommend using them. It'll make the project a little easier for you.
Is it just a summarization of what we've been doing, or?
So kind of what we're looking for here,
No.
down here, is kind of a summarization of like the different disasters that happened through the semester, ones that you guys looked at or any other major ones that may have occurred. And so kind of what we're looking for is just like a quick write-up on where did it happen. So, the type of disaster, some of these you don't even need full sentences, just a quick, or full paragraphs, just a quick sentence saying the disaster occurred, in Dongwang, China, and it was an earthquake, or, whatever. But, I think the easiest thing for you to do literally is just, copy and paste these bullets right here and then fill them out as best you can. So that'll kind of help it. Make sure you have everything. So things to make sure you definitely have. Make sure you have a reference there for me to see. So, CNN or whatever, wherever you find it. And then anything you can find on the economic and human impact. And then obviously where it was, what type of disaster. Mitigation, try to put something, but if you don't see anything there that they said that they could have done for mitigation, you can also write about what you think could be done to help mitigate that thing, that disaster, whatever it was, or mitigating future disasters of a similar nature. That'll be totally fine.
Okay.
So, typically for each disaster, each person, it typically does about a half page for each one. So, the 2 volcanoes would take up a full page. Kind of give you an idea on length on how much they're writing is what I'm looking for. Some do more. Doing less kind of starts making, it's kind of hard to get everything in, but that's kind of a general what I've seen.
Yeah.
So, okay. Any other questions on this?
No.
My little granddaughter's answering you. Sorry, Brother Northrup.
That is perfect. She's probably the best person here for us.
My name is Peyton.
Oh, well, it's good to meet you.
Her name's Peyton, she said. Sorry about that.
Oh, it's okay. Okay. Well, with that, probably today won't be too long. I just want to go a little bit over some of the stuff with flooding that we talked about. Let me get the right presentation. All right. Can you guys all see the presentation okay? Or is it still back on the one?
Sorry.
Let me make sure. Okay. So we'll just kind of look through, we won't spend too much time on here. So this is a flood in Cedar Rapids, Iowa, a couple of years ago. I'm actually moving about 30 miles south of here after this summer. So anyway, I'm not going to spend too much time on these first couple of slides in the first presentation. We'll probably spend most of the time on the second and third. But I do want to go over a couple of things for you guys real quick. Flooding can be kind of caused by a couple of things. So you've got snow melt just up in the mountains where the snow's accumulated over the winter. If it starts to melt relatively quick, or you've just had a really, really big what's called snowpack year, where you get a lot of snow accumulation up in the mountains, and just as that naturally starts to melt during the summer, if your rivers aren't big enough to handle all the water, that can cause flooding. Let's see, there was a couple others, and we'll talk about first actually types of floods. We'll go follow this. So there's flash floods, right? And that's just where you get a lot intense rainfall or something, and it causes really quick floods to come in. Let's do a quick video on this. I like to show videos. I think it kind of illustrates the point. Now, if we can get it to load, it kind of can show you. Yeah, we'll show this one in Utah. We're going to mute the guy.
I put that on everything.
There we go. Oh, So you can see this is a flash flood just coming down a gorge. There was some big rainfall back up in the mountains, and they move quick. They move really, really quick. These are a little more common in kind of arid regions to semi-arid regions, like desert, like Arizona, Utah, Colorado, different places like this. And basically what's happening is there's so much water coming down. It's not the soil can't accommodate it. It doesn't have enough time to absorb into the ground. So it just starts running down the rivulets and the canyons. And you can see, it's a lot of water really quick. This person probably shouldn't be standing around here either. So kind of gives you an idea for what this is like, what these are like. Let's see. Up here again, you can see the water is really moving really quick. And these are really, really dangerous. Okay. And this is the key thing too. This kind of point right here, most fatalities from flash floods are motorists. Whether that just be people who are crossing a gorge and the flood just hits before they even realize what's happening, or people who think their car can make it across. That's commonly what causes the fatalities in these, is people just not thinking things through, going into areas when there's high rainfall that are prone to flash floods, and trying to cross the streams and rivers that are flooding to try and get to higher ground. So that's kind of the thing, the main points with the flash flood. Then you've got just normal river flooding. This is like kind of like what we saw back out in Nebraska and the Midwest. You get a lot of snow up in the mountains, a lot of rain, and just as the snow melt begins to melt, or snowpack begins to melt, and as all the water start from the rains and the melting snow comes down the rivers, it'll eventually all coalesce right into the main river. And if there's been more precipitation than usual that year, it can cause the river levels to rise, which can cause flooding. There's different types of flooding. There's minor flooding. So this is when there's like, the water level goes up. There's not really property damage. It might be kind of inconvenient for people, but it's not something you need to worry about too much. Then there's the moderate flooding. So you have some structures are sunk and roads near streams. Some areas are evacuated, but there's the higher elevation stuff, and a lot of the towns are fine. And then you have major flooding, which is extensive, as it says, inundation of structures and roads, significant evacuations of people, and transfer of property to higher elevations. Here, this first picture, this is major flooding right here in the city of Cedar Rapids. So you can see the whole city's inundated across. The roads are covered, even up into probably the first story is almost completely underwater. So that's an example of major flooding. So let's go back down here. Okay. Then you can get flooding from cyclones, coastal flooding, and we'll talk more about these as we get towards the hurricanes not next week, but the following week. But basically, you get the big storm surges that come in with the hurricanes carrying a bunch of water and can flood in onto the coast. And then you've got snowmelt flooding. So typically this isn't a problem, but when you have really warm conditions after a really moist winter and heavy rains, it can cause a lot of flooding. Typically, this will also associate with river flooding. And then you get ice jam floods. So this can happen with snowmelt floods, right? So your rivers, this typically will happen more towards the early spring before you have everything completely thawed. And so you'll have some, ice coming down the river, and what can happen is all that ice can kind of coalesce, let's say under a bridge or something, and it can create a dam that can actually cause the water levels to rise and cause flooding. Also, the ice can also deform the bridges and cause all sorts of problems with structure and integrity of buildings and whatnot, whatever it's lodged onto. So that's kind of the big things that I guess they also say mud flows, but I'm not going to talk too much about that. We've talked about that already with landslides. So just a few terminology things, slot canyons. So these are those really, really narrow canyons. You see there's a picture of one right up here. This is a slot canyon right here. Basically, you get hundreds and hundreds and hundreds of years, just years and years and years of erosion going on from water flowing through here. That's why they have those beautiful curvilinear walls and everything. These are really, really prone to flash flooding. You get any water, any rains, it's all going to funnel down into these canyons. They're narrow, the water gets deep, it moves really quick. So you'll see a lot of people talking about them with an association with flooding, hikers getting caught in those. That's what a slot canyon is. And you have what's called an alluvial fan. This is an alluvial fan right here. This big fan-shaped thing coming out of the mountains. Basically, I like kind of how they put it here. It's a fan-shaped apron of gravel deposits by flash floods and debris flows. So basically, all your water's coming down down out of the canyon, and the water's moving so quickly, it's carrying materials with it, whether it's a debris flow itself or the flood is just a flood that's carrying some boulders and rocks. Regardless, it's going to come down, and it comes out of the mountain, and it starts out of the mountains and starts depositing these big aprons of gravels and whatnot. And these are alluvial fans. You see these along almost any mountain range as you're going down, as you're driving by. You see them all over the place, particularly California. California has some really great alluvial fans. They're really, really big. So these are also associated with flooding. So I think that is all I want to spend time with on this. Any questions on any of this section of slides? Okay, we'll go this one here. Oh, if I can move this, there we go. So we'll probably spend a little more time here. I think I just missed the chat. Let me see, give me a second while I open that. Okay. So we're going to talk about river systems real quick and the different types of river systems. So as a geologist, this is what gets me excited. Rivers is the type of rocks I like to look at are the rocks that are deposited by rivers. So this is probably why I want to focus on this. I don't know. Also because rivers are the main point. So you've got two types of rivers. You've got meandering rivers, and then you've got, I'm going down here to show you the other one, braided rivers right here. Okay, so we'll start off with meandering rivers, and these are those big rivers that just kind of snake their way across, right? This is a picture, this figure right here is a great image of a meandering river, just kind of snaking its way down across a big channel, snaking its way down across, you know, the valley or wherever it is, okay? So they have these big bends in them, and the river is actually migrating over time. Let's see if I can find you a good image. Well, we'll just use this one up here. So as the river's moving, the water's flowing, and it's eroding this edge right out here, and it's depositing right here. So this bend is getting bigger and bigger and bigger. And then this bend is getting bigger. It always erodes on the outside edge, deposits on the inside edge. So that's kind of the physics that's going on right here, why it's kind of so bendy and curvy. These inside edges are called point bars. And they're growing at the same rate for the most part that you have erosion going on along this outside edge. Eventually, what happens is these bends can get so extreme that they'll actually get cut off. The river will say, you know what, it's actually easier to move the water through over here rather than all the way around this bend. So they'll actually all of a sudden abandon this channel and create a new channel going through right here. And those create what's called an oxbow lake. Here's a good example of this. You can see a meander right here coming around, but you see right here, this channel right there. So this channel is starting, this river is now trying to go right here instead because this channel right here was too much. It was less work for the water to go through here than for the water to go over here. Mother Nature is lazy, and it's always going to find the path of least resistance, just like all of us. So that's exactly what it's doing right here. So it'll cut these off, and all of a sudden, no more water is going to be flowing through, and you can even create little lakes. Let's see if there's a good image of an Oxbow Lake. No, but that's okay. This map right here, this is a historical map of the Mississippi River. Hey, bud, you going to bed? Give me hugs and kisses. Love you. Good night. This map is just showing all the different meanders and bends and just ways the stream and river has moved over time. And you can see it's really hairy, it's really confusing, and that's kind of the point, is just to show that rivers are dynamic, particularly meandering rivers are very dynamic, and they're just going to change, the channels are going to change location frequently. Okay. Some more things. So here's your point bar right here with your sands. They also call them sand point bar, either one. Your cut bank is what they call where the erosion is occurring. So that's what they're just trying to show with this figure. Then right here, this one's kind of just breaking down a cross section of a river. And what I mean by that is, you've cut the river in half, and are now looking at it straight on. And you can see you've got right here a couple of different things. You've got the channel, or in this case, low flow channel. Then you've got the hydrological floodplain, and then the topographical floodplain. So this right here, low flow channel, that's just the channel during normal times. That's where the river is normally when it flows. The hydrological floodplain is a wider depression that's kind of filled with water during seasonal high water. Basically what that means is like right after spring runoff. This is when the river is typically the most full, but not quite flooding. And then your topographical floodplain, this right here, this is about as high as the water gets when it floods, like serious flooding for the most part. So this is saying when this river here is flooding and flooding stage, the channel can be this wide. So you can see there's actually a huge, if you will, possible change between where the water is normally right here, all the way up to serious flooding in the topographical floodplain. Kind of key takeaway though is your hydrological floodplain, your channel are kind of where you want the river to be, you expect the river to be when it's not flooding. This is an image showing that of a normal river. So this is the Mississippi. You've got a leveed floodplain, which is kind of the same as this hydrological floodplain, right? We've just built these levees here. They're acting to contain that river. So just during normal season, when it's not necessarily flooding, this leveed floodplain kind of shows the extent of what we expect the water to be. Sometimes it's lower than the levees. Sometimes it's right up to the levees. But that's kind of the where we expect it to be. Then you've got this topographical floodplain. You can actually see it, right? You've got these little bluffs running over here. You've got bluffs running along this other side of the river. And when the Mississippi in this area floods, it will fill this entire area. Or it can, at least, depending on the degree of severity of the flood. So you can kind of see how dynamic these rivers are and how dangerous they can be when they all of a sudden put that much water out. Then there's what's called braided rivers. So this is typically when a river has a lot of sediment moving in it. And all of a sudden it's got so much sediment that it starts depositing in areas and it kind of braids around. It can't form one solid channel, and it'll form hundreds of different channels moving throughout. So you can see here, here's this kind of main trunk of the channel running through here, but then there's hundreds of little tributary channels coming off. This is just the effect of a high sediment load, meaning there's a lot of sediments moving in with the water. These are typically shallower too, whereas these braided river or these meandering rivers are deeper. So these also tend to be faster moving. So you think of the Mississippi, and there's not really going to be big rapids and things coming down the Mississippi, but these channels are moving pretty quick. They're often up in the mountains, kind of coming down off the mountains, right after the alluvial fans and stuff. So these are, they're still moving pretty quick. These aren't going to be roaring rapids either. That's a little different setting, but this is a fast moving, relatively fast moving water. And this one's in India. And here the floodplain is about 7 to 10 miles wide. So kind of this whole area here is about 7 to 10 miles. See if there's anything else I forgot. So I guess this point here is also important. I mentioned that they're fast moving. Because they're fast moving and can carry rocks, they can cause more erosion and structural damage, especially if you have like a bridge or something and it's beating up against it. It's harder on the materials around it that it's hitting. So here is the Snake River in Idaho. This one right now is a braided river. You can see all the braids and tributaries coming off. Here's the leveed floodplain. Here's the topographic floodplain. They're saying to here it's probably maybe a little bit higher by here, but yeah. So you can see, it looks quite a bit different. And you can see old channels up through here and everything. And these channels will be frequently changing. These channels are not stationary. They're moving just like the meanders in the meandering river. These little guys are moving all over the place all the time. Even within a few years, it'll look completely different.
Brother Northrop, I see that in rivers in
Mhm.
Texas all the time. When there's a lot of rain, it's higher. You don't see all that. Then when it dissipates, you'll see all the different, different areas that they've run off or gone through.
Yeah, and that's, kind of that point is, you get all that rain and all of a sudden it's carrying all this sediment down. And then as there's less water moving through the system, there's still a lot of sediment. So, kind of the sediment to water ratio changes a little bit and it starts to form these, like you're saying. Mm-hmm.
Hadn't even realized it till we studied this. It's
Yeah.
cool.
No, it's pretty cool. Then you got mountain streams. These are a lot straighter, a lot faster moving. This is your whitewater rafting stuff, your big, your big rapids and everything like this. And when you get flooding, that comes roaring down here. These moves really quick. They can carry huge boulders and big cobbles and everything. As you can see here, this is a flood. Where's this one at? Does it say? Oh, Big Thompson Canyon. And you can see these boulders here and these big cobbles, they're all transported down by the water. That's how fast and powerful the water is coming down here. This is after a flood, but even normally it can carry cobbles the size of, it'll roll cobbles the size of your head down some of these mountain streams. And once you get flooding, you'll get whole boulders coming down. Then we've got what's called drainage basins. So this is basically what a drainage basin is the area that drains into a river. So this is the Mississippi River Drainage Basin. And basically everything within this outline, all that water goes into the Mississippi and out into the Gulf of Mexico. So the drainage basin is just the geographic region that drains into that particular river, that major river. This is something you look at with major rivers like the Mississippi, Missouri, the Colorado, things like that. And then you can subdivide it into sub-basins for the tributaries. So like right here looking, let's say this is your big Mississippi or Missouri. And this would be a smaller tributary, like let's say the Iowa River. This would be the sub-basin of the Iowa River, and this would be the sub-basin of another one. Each river has its own drainage basin, and so you can break it down as far as you want. So let's see, is there anything else I want to say on this? Yeah, so these are important with regards to flooding, because let's say you got the Mississippi down here. Well, let's say Montana and the Dakotas and Colorado and Wyoming over here have a really, really, really snowy winter. and then it has a really, really warm spring. So all this snow melt up here can cause flooding over in here, and over through here, which is exactly what happened with the recent flooding that we've seen in the Midwest. A lot of it came from the Rockies, all the snow melt and everything over in here within the Mississippi River drainage basin. So why this is important, why this image is so important, is it kind of gives you an idea of how something over here in Montana can actually affect something all the way down here in Louisiana. Typically, it'll affect more up through here as well, if it's in the Rockies. But, if you have a wet winter all up in these areas, you can have a lot of flooding down in the south. Erosion, basically, as you have water moving through, it'll erode out the sediments and can cause a lot of problems. It can take out not just the sediments, but it can actually remove even rocks and bedrock in some cases. But this is kind of a key real thing right here. Hard bedrock erodes very slowly. So if you're built on bedrock, you're typically a little safer. You're not going to have your foundation eroding out of you, but it can still erode, and you still have to worry about water rising. So I don't want to spend much more on that. Here's some of the flooding. I think this is an image from one of the floods in the case studies, but a flood here in Utah. Oh yeah, this is the Santa Clara, which is a case study. So you can see the water's come down and it's moving so quick. It's been eroding back this cliff or this bluff, and now it's basically in people's backyards, and their homes are starting to collapse in. So that's another one of these dangers about these floods, especially flash floods, is they cause a lot of erosion from the fast moving water. And it can, really, really cause a lot of damage. You could be, I think these houses were quite a ways back from the river, but it just ate through all of this soft sediments.
Seems like they build bulkheads and stuff when they build those areas like that.
They try to, I think. We've learned our lesson, hopefully, but
yeah,
what can you do?
Yeah.
Okay, I think that's that on that one. This one, I'll just explain this figure here. This is talking about discharge, the discharge of a river. So river discharge changes based on how much water is moving through. This is just saying how you measure discharge. So discharge is area times the velocity. So it's the area of the river times the velocity. So basic, and then your area is calculated by your depth and then the width. It's just kind of, for anything, I don't think you guys really have to do anything with this, but if we were going to do it, we'd do it real simplistic and just make this a cube or a rectangle and just say, okay, that's the depth, there's the width, calculate that to get your area, then you use your water, the velocity of your water, just how fast it's moving, and that'll give your rate of discharge. It's just saying so much water is coming out right here. This is another good figure, because this figure kind of helps you see, understand how flooding works in timing. So what this is showing here on your x-axis, this is just showing the time. From right here, let's say this is when the rain starts to fall, to all the way out here. And then right here on your y-axis, this is your rainfall and your flow or discharge. So it's kind of showing two things. Rainfall, because right here it's just showing you get all of a sudden, you get a lot of rainfall right up here. And then you notice that there's a kind of a lag right here between, this peak and kind of the peak time, the peak flow as well, peak discharge. Then that's just because all the rain up and a ways away has to start moving down the system. You have to also saturate the soils so that the water is no longer going down into the soils. So that takes a second. You're filling up the soil, and then all of a sudden, okay, the soil's full. Now all your water's flowing out, and it's flowing down the rivers. You're getting your flooding, and then from there it starts to slowly decline off as your system is trying to get back to equilibrium. Okay, this slide's talking about 100-year floods. So this is kind of an important thing to understand. Because when you're looking to buy a house, a lot of places will say, okay, you're in the 100-year floodplain, you're in the 500-year floodplain, you're in the 50-year floodplain or whatever, and they'll use that for insurance purposes and just various different things. But it's important to understand what we're actually talking about here. So this sentence in purple describes it really well. It says, because a 100-year flood is the biggest one that happened only once in the past 100 years. Statisticians would say that it has a 1% chance of happening in a given year. So what they're saying is when you live in 100-year floodplain, is statistically there's only a 1% chance that a flood of that scale will happen where you live that year. That's not guaranteeing it. It's just saying your chances are 1 in 100 that you'll have a huge flood come through here. But it's solely based off of that of a past measurements, and kind of it's not really anything sound, and it's not something you should really you shouldn't base decisions in buying a home solely on that. You need to recognize that there is a chance you can have multiple 100-year floods within just a few years, even 1 year, which does happen. Does that make sense to everyone? So it's just a statistician thing. Okay. So, and if you want, you can look at this poster here. It explains it. Sometimes it's better to see when you can read it as well. Then there's a couple of things we'll just go over briefly real quick with flood mitigation. Dams, obviously, you can create a dam so the water can accumulate, and then you can control water levels. So this is a really good way. You can fill up a reservoir, which can prevent flooding. Where your risk comes is if you have too much water for even the dam, then you can start overflowing your dam and your spillways. Some of the things that could be positive or negative, depending on what you're looking to do, is you can have profound changes on the actual river system itself by stopping sediment flow downstream. So you'll start building sediments along the backside of the dam, and then all of a sudden on the other side of the river, you're not going to get the sediments going down the river. So that can have ecological effects on your fish and wildlife. It can also cause problems with fish migration.
I know in Louisiana they use the Atchafalaya Basin as a flood mitigation type thing, where they'll redirect water to there if it's heavy in New Orleans or Baton Rouge.
Yeah,
like that gets out in the basin. So the basin's a good thing for that area.
Yeah, and that's when some of the power with some of these things is, you can, let's say you've got a dam or whatever, you can shut everything off, and if you have another alternate spillway, you can start sending water somewhere else and fill other areas. It's true. It can really help. Then you got your levees. So you've got natural levees and man-made levees. Basically, that's those kind of walls that are along the sides of rivers. They say berms as well. So let's see. Let's look at the picture here. Natural. We'll show you what a natural levee looks like. Here we go. This is just kind of a levee right here, just a natural levee, where you've got kind of just this little hill encasing the river, and the river sits down a little lower. And basically that's just causes when the river overflows, it drops sediment there and it just builds this hill up a little over time. Or vegetation likes to grow there and builds the hill up. Whatever happens, regardless, you get these little kind of mounds along the edges of rivers, and those will act as little barriers or berms to contain the river. That's what a natural levee looks like. That's kind of how they're built. And then you've got man-made levees. Right, like here where you've actually built in a wall or a berm to kind of protect your the surrounding areas. So like here's a good example where they've built it themselves. So these are really great. You can control your river and kind of direct flow. This is what they've been doing in New Orleans for, hundreds of years now, basically, is they built these levees. They can control the flow of the Mississippi and force it to go where they want it to go and kind of keep people safe. But there is, so they're really great in that way, but there is some weaknesses with levees, which is obviously they can break. A great example of that is, what happened with the hurricane in New Orleans when a bunch of the levees broke. You saw how bad the flooding was, so that can cause a lot of problems.
So I had a good friend
Mm-hmm.
just recently. I was talking to. He was put in charge of the Bureau of Land Management in Louisiana after Katrina.
Okay.
And he was tasked to rebuild all the levees to make them safer in that area, and he did in Louisiana. It's crazy.
That is a big job.
It was a big job.
It was a huge job.
Yeah, Lieutenant Governor put him in charge of it, and he did it.
Yeah. Wow.
Crazy job. Yeah.
That would be a lot of work.
Yeah.
So yeah, I also like this paragraph right here. I think this is really good. Brings up a couple other things that we need to think about with levees. So they can also have effects in the river that may not be obvious at first. So they can create a bottleneck or narrow passageways that can cause the rivers to back up, which can increase severity of flooding. So sometimes you get that bottleneck, which can cause problems. So here's some great images of where levees have broken. Here you see the levee broke right there, and now it's flooding out. This poor guy has lost his house. A lot of destruction, a lot of problems when your levees start breaking. And the levees also broke right here. And you can see, it comes spilling through when these levees break. As a matter of fact, let's see a video here. Yeah, we'll just do this one. So there you go. This is what it looks like when a levee breaks. So it's a pretty big deal. It's pretty serious when these levees break. Because you can see the amount of water that is just pouring down into this areas. And let's say like Louisiana, you've got your levee here, and then 100 feet this way, you've got a neighborhood. All of a sudden, this neighborhood now is being filled with all this water coming down through the spillway that where the levee broke. It kind of gives you an idea. All right, let's move this back here. Oh, that's right, we need to go back. So there's different types of levees and kind of the anatomy of a levee. I'm not really going to talk too much about this. So it shows a couple of different things, just some of the problems you can have with levees. So you get overtopping, which is basically the levee doesn't break. You just get more water than the levee can handle, and it just goes over the top of the levee. You've got overtopping and jetting. This one, internal erosion and piping. So basically, all of a sudden, something happens, and the water can now go through the levee. It's more like a membrane than an actual wall. So it just kind of passes through the levee. You got surface erosion where it breaks to the top. You got sliding where the water actually starts to push the levee. Wave impacts, the waves can go over, the waves can erode it down and break it apart. Structural impacts, your big tankers or whatever, boats or boulders or whatever's going through can hit the levee, weaken it, and the water can break through. Liquefaction, basically the water gets in and the levee kind of just sinks down. Piping of substratum. This is basically where the water doesn't go through the levee. It's similar to this one with internal erosion piping, but it actually goes under the levee and through the ground, whether it be through the rocks or whatever's down there. It finds a porous, permeable layer of something and just travels along that and goes through. Tree damage, so your tree's going through, you got roots going through the levee and it weakens it, and then water breaks through. And then you've got slope failure, so your levee just, you have a basically chunk of the levee falls off, and that can cause, all these can cause levee failure. So here's an image of a levee. You've got channel modification. So, this is another form of mitigation, which can include levees, building levees. This can be putting up vegetation, widening channels, or, as kind of what you were saying, James, a little bit earlier, sometimes you can reroute it. In this case, they're rerouting it over into the basin, which is, it's a little different, but it's kind of a similar idea where they're modifying where the original channel is. They're saying, okay, let's move it over, or let's redirect it somewhere else for now, so the water spills into an area that is okay to flood.
Right. They do that at the Chaffalot Basin all the time. So
Yeah.
I'm used to that. I'm from Louisiana, so. Anyway.
So you know this.
Oh yeah.
Yeah. You can also use riprap right here. This is basically put a blanket of boulders, size rocks, designed to kind of prevent erosion. Your water's not going to be able to go in and rip these out, because these are, the size of people, bigger. These are thousands of pounds of rocks. It'd take something catastrophic to move these. And so you can basically put this on top and kind of fortify your walls, so that the flood's not going to come through and break through. So you've got some other factors in flooding. So there's urbanization plays a role in flooding. Namely, when you urbanize an area, all of a sudden you cover it in concrete. And concrete and water, water can't go through concrete, whereas water can go through soil. So urbanization can actually cause worse flooding, because all of a sudden the water doesn't have anywhere to get down into the ground. That's kind of one of the major things that you see. So all this rainfall here is just going to travel down the streets, pool in these areas, the lowest elevation areas, and you can get a little bit of flooding through these downtown areas.
They did it here in Pearland, Texas, and it flooded on one end of our city a lot.
Yeah.
And they finally came in, Army Corps of Engineers came in and made them start building runoff ponds.
Yep.
Because they were actually using the street as the drain.
Yeah.
And once it came over the street, it was flooding homes. It was ridiculous.
Yep. That's exactly why urbanization, if not done properly, can cause worse flooding.
Yeah.
Sedimentation, if you get a lot, let's see what they're saying here. Yeah, okay. So when you get flooding, you can get a lot of sediments like silts and clays and sands and all that stuff coming in the rivers. So what happens then is you get the flooding, and it's taking that stuff everywhere. And then when that goes away, when all that water recedes, it leaves all those sediments and silts and clays, and it can make the cleanup significantly harder and worse, because now all of a sudden you've got 1, 2, 3 feet of silt and clay you got to dig a house out of. You saw that, and you see that all the time, where you see these big flooding events. People then having to go, start getting wheelbarrows, and they'll literally have to, scoop 6 inches of mud out of their house. So that sedimentation can make flooding worse. And yeah, I guess your climate and your landscape can also affect it. So your drier, arid areas can cause a lot of problems, where you've got a lot of clays and different things, and impermeable materials. It can make flooding worse because it can't get through the bedrock, or the water can't get through the bedrock as easily, so more water accumulates in the channels. Let's see what else they're saying here. Yeah, basically what I was saying. So they just go a little more in depth here. I don't want to spend too much time here. Yeah, so you can also have atmospheric conditions where things like the Pineapple Express, El Nino and La Nina years, different things like that, that can actually alter the rainfall, where it happens, the amount, and that can cause flooding. Here they specifically mention the Pineapple Express. So just the kind of the key takeaway right here is just that, you can get special atmospheric conditions that can worsen flooding as well in certain years. So I think that kind of sums up everything here with this, with the flooding. Any questions from anybody? Okay. So I hope this is helpful. Hopefully, you guys understand it a little better. Make sure you're starting to think about your semester projects, so the semester project. And, I would again just recommend using that template that I showed you guys. It's right in the description of the project. So just on the announcement that I posted on Monday, there's the link to the project description. You just click on that. It'll take you right there. Go down, and then number 8 of the points. You can literally just copy, paste that, and then fill in for each disaster, and it'll make your lives easier. It'll make my life easier too, because it's a lot easier to grade that than it is to go through a whole paragraph and pick everything out. So I would highly recommend using that for you guys. If you don't, I'm not going to dock you points, but I feel like that'll make it a little easier for you guys as well. Just to make sure.
Better to answer the individual lines and stuff instead of writing major paragraphs.
Yeah, just like a good paragraph for. Let me go back to it here. Let's see. Just a good paragraph. You don't even need a paragraph for location of disaster. You just outline the place. So, for example, and this is something you should do, kind of a note here because I've seen this. For example, when in some of the guided labs, when you put a location of a disaster or areas that might be prone to a landslide, and you put something like Indonesia or Russia or China, well, that tells me nothing. Just because these areas are huge, they have a bunch of different type of topography and geology in the areas. So, for example, with this last guided lab, one of the ones is name an area that might be prone to landslides, and a lot of people would just put China. Well, yeah, there's a lot of areas in China that are prone to landslides, and there's a lot of areas in China that are not prone to landslides. So when you're doing your disaster report, make sure to put like kind of a specific region, say this happened in China near the town of or in the province of, and that'll help. That narrows it down, and I am looking for that. And then when it's like type of disaster, you don't even need to put a sentence there. You can just put hurricane, earthquake, or whatever the disaster is. And then make sure you got the dates. And then for the description of the disaster, you want a good paragraph there, kind of outlining what happened, a good three sentences saying, let's say you've got an earthquake. So a magnitude 8.7 earthquake occurred near the town of Kobe, Japan. I actually don't remember if that's the right size of the Kobe, but Kobe, Japan, along the along near this plate boundary, it occurred, and just kind of a brief description of it, describing what happened. Or this will be especially useful when you talk about the land, or if you use anything like a wildfire. Then a little paragraph on economic loss, if you can. If you can find dollar amounts, great. If you can't, just outline, what you saw. A lot of times they'll list how many homes were destroyed or how many people were evacuated, things like that. How long services were down. So outlining that. Total number of human casualties, just list what you can find. You can just list that. You don't even need to really write a paragraph there. A nice reference there, so just referencing it. And then mitigation. I talked about this briefly earlier at the beginning, but we'll go over it again. So outline in a nice paragraph again what type of mitigation was done for it. If there was none, you can say that, and then what they could have done to mitigate it. Or you could do something like what they could do to mitigate against a future disaster of that similar type. And that should do it. I know it seems like a lot. This is a big project. It is 100 points, so it's worth more than the final. So I would recommend spending time here. This is a real grade booster or a real grade destroyer, depending on how you do. And again, the other thing I want to note here is you're doing multiples. So you're doing 2 earthquakes, 2 volcanoes, 2 flooding, 2 mass wasting, 2 weather related. So that's like hurricanes, cyclones, tornadoes, things like that. And then 2 others. The others can be wildfires, coastal erosion, and we'll have a week on that where I think it's week 13. You guys will have mini case studies where you choose and do a small presentation on wildfire or something of your choice like that. So, you are going to be doing 1, 2, 3, 4, 5, 6, 12. There needs to be 12 total that need to be presented to me. Some people sometimes just do 6. So that'll give you an automatic 50%. That's the highest your grade can be. So make sure you're doing the total full number of these. And like I said, this is a really good way to pad your grades at the end of the semester. Do really well on this. It can outweigh, counterbalance the final a little bit.
Can we use our guided lab stuff that we've had?
So you'll want to do, these are current kind of things that are happening just real recent. So, and that can be hard. I know, especially with volcanoes.
Yeah.
But I do want to say in the project description here, it'll tell you to do stuff that happened during the semester. And I'm lenient with that, especially since I don't really know of many volcanoes that have erupted in the last year. So there is one, that's Kilauea, but that happened, a year ago, literally. So if you need to go back a few years for a couple of these, that's fine. You should have plenty with flooding, plenty with weather related. There's always hurricane season within the last year, and then you've got all the tornadoes from this last tornado season. Then there's been a couple of landslides you guys can use, and there's been a few earthquakes as well. But if you want a bigger earthquake, you can go back into last year as well. But try and keep them as recent as possible. So, okay. I think that's all I'm going to say here. If you guys have any questions as you're working on these, just shoot me an email. We can talk about it. More than happy to take a look. You can send me something, say, hey, is this kind of a good idea, a good disaster? And I can read through a link you send me to a report. I'm more than happy to give you feedback on that. So with that, I think that is all I want to spend time here on that. Any questions from you guys about anything? Okay. I'm going to stop the share. All right. Okay, yeah. Okay, I think then we'll stop recording. I think that sums it up.